Hello and welcome to the C4C equals Unpacking the Potential of Circular Economy for a Sustainable Future-Proof Public Transport. In this case study, I will introduce you to our experience in designing and implementing a universal electric tram door controller. My name is Attila Nádai and I am the Technical Chief Engineer for the Szeged Transportation Company. First, I want to introduce our city and our company. City of Szeged is a third-populated city in Hungary with almost 160,000 inhabitants. Our company, the Szeged Transportation Company, is a 100% municipality-owned company. We are operating the tram and trolleybus lines of the city with 42 trams and 55 trolleybuses. The challenge we identified was to keep our old fleet moving. Here are some examples of our classic Tatra trams, the T6 and the KT4. Although the original manufacturer of the trams no longer exists, we will have to use these robust trams for the next decade. One of the key components of the tram is the door control unit, as there is no original or replacement product on the market. Due to the operation of the safety-critical door systems, we also had to meet safety requirements. Our goal was to acquire the know-how needed to manufacture these parts, thereby making our company independent from the existence of external key manufacturers. We need to replace the original control units in order to extend the service life of the Tatra trams. The solution must be exchangeable with the original controller. It should have a parametric configuration. It should have a modern diagnostic tool, and it should meet modern safety requirements and fully comply with the regulation of the Transport Authority. We searched similar projects in Hungary. There was a similar door modernization project at the BKV, which is the largest domestic tram operator company in Hungary. Based on that experience, we initiated consultation with the experts of the BKV, industrial hardware developer company, the authority, and the certification body. The key development phases are the preparation of the documentation based on the original documentation of the trams. We had to make a tender to find the hardware developer and manufacturer partner. We had made a test environment with as many original tram parts possible. As part of the preparation, a detailed technical documentation had to be composed. Fortunately, we had the original documentation from the 80s, which was so precise, not as nowadays. For the test environment, we had to set up a detailed door unit in the workshop. The expectations of the diagnostic capabilities were determined from the experience of the modern devices. As part of the stakeholder engagement, we involved the Transport Authority from an early stage to ensure legal compliance. We involved a certification body to validate the final product, and we consulted experts from the Budapest Transport Company who had already successfully implemented similar projects before. After all, we built a close, ongoing collaboration with the contracted development company. In the implementation phase, we first launched a tender to find a suitable partner for the development and production of the controllers. The development partner had to design the unit, produce prototypes, and test them in a laboratory. The partner had to arrange for the approval of the certificates by a quality certification body. Due to the short time frame of the project, series production had to start as soon as the product was meet the requirements based on the interim reports. Although the hardware design cannot be easily modified afterwards, the test later required only software modifications, which could be easier to handle than hardware issues. The transferability and future use of the project. Many of our trolleybuses operate with similar electric door systems, where the door control unit could be applied with further developments. The experiences of the project will form the basis for a spare parts replacement strategy for critical tram and trolleybus components. The project sets a precedent for future in-house innovations and authorization procedures. The take-up aspects from pilot to business as usual. What the SKT already keeps from this project? The in-house engineering and testing experience and methodology. The integrated diagnostic software and maintenance protocols which developed for the new unit based on our diagnostic experiences. The early regulatory engagement as a standard practice. The involving the experiences and use cases of other PT companies and strengthen these professional relationships. Finally, for similar projects, a multi-level testing procedure should be calculated in similar projects with its time and resource requirements. And how it became standard. The documented processes added to the XKT's technical standards. Knowledge retained for future modernization like vehicle doors and climatization systems. Transferability to third parties. There are key transferable elements in the project. First, the universal hardware design of the door control unit, which is adaptable to other operators. Other point of the experience of the certification process. And finally, the extended and personalized diagnostic features in the upgraded unit. There are some other opportunities. The project offers retrofit kits and expertise to Hungarian and EU operators. The project also strengthened the SKT's role as an innovation partner in the public transport technology. As an expertise advantage, a local development partner involved into the PT technology. Finally, I would like to thank you for your attention, and I hope that you will be able to benefit from the experience of our project. For any more questions, you can get more detailed answers from the project study.